on the remaining topic for remaining semester. So before we go further, I'd like to share with you that what I have learned, what I have made decisions on this thing. For example, if you can see from here, so actually we are in the week 11 lah. Sebenarnya kalau ikutkan kita dalam week 11. But I shifted the early topic chapter 3 in this week 11, yang mana kalau kita lihat sini sepatutnya week 12 tu kita baru mula chapter 3, tapi minggu ni saya mulakan online dengan chapter 3 selama 3 minggu, and then remaining last 2 weeks dia akan cover balik chapter 2 untuk week 10 and week 11 yang sepatutnya adalah practice hands-on simulations for excavation in sand and also embankment. So I think that I leave it for you 2 weeks here to complete your project, but you still need to click the attendance as a recorded video. So I also give links for you to have self-learning on the excavations in sand and also the embankments. So actually during these 2 weeks, for the last 2 weeks in January, I give it for you to have your personal time to complete your projects, and please remind on the submissions project will be on the 30th January 22 before 5 p.m. So please while you preparing the projects report, please fulfill all the rubrics lah. Contohnya kalau kata rubrik tu minta apa item-item, ada chapter 1, chapter 2, chapter 3 ataupun kandungan pertama, kandungan 2, kandungan 3, 4 sampai habis tu, so you kena ada lah. And then another one is on the appendix. I nak you attach the original article that you referred to conduct or to have your projects on Plaxis. So without that original copy, I may assume that you are copy from someone project ataupun you ambil daripada Bentley punya website or something like that. So the thing is that you choose any case study yang you prefer untuk buat, kemudian you buat balik modeling simulations in Plaxis, attach your report and original copy, and then you tulislah sedikit. Okay, untuk makluman juga, dia akan cover markah untuk final assessment lah. Final assessment ni kita ganti dengan satu project dan juga test. So for test will be as scheduled in the lesson plan, will be on 8 February 2022. If you look at from this date 31st January sehingga 8 bulan 2, I just remind every one of you, you only have few days sahaja dalam revision week untuk you cover balik chapter 1 dan juga chapter 3 if I'm not mistaken, that will be asked in your final assignment. Kat sini kita panggil lebih kepada final test lah, final assignment ataupun test. So 2 chapter daripada 4 chapter yang you kena concentrate lah untuk lebih sikit pulen. So chapter 3 ni kita akan cover minggu ni, hopefully you ada berbaki 1 minggu, 2 minggu, 3 minggu lah untuk you buat revision sebelum final assessment ataupun final test. So untuk chapter 3 ni, kalau you look at from here, actually we are focusing on the geotechnical application by using the Eurocode. Kalau kita remember in the early course CG 612, we have sections yang mana chapter 1 tu berkaitan dengan soil modeling, and then chapter 2 how do you design for complex retaining wall, you look at with the anchor effect, kemudian ada surcharge effect, water table effect, and that one you are designing using the conventional method ataupun British standard method. Conventional method ni contohnya gross method, simplified method. Okay, tapi untuk kali ni bila chapter 3 ni you are doing the same analysis for retaining wall for example, but then you have to fulfill dengan Eurocode punya standards lah. That's how it try to explain to you in this topic. So without further ado, I'm going to share with you for the next slide in the chapter 3. Okay, can you see this one? Alamak. Sekejap. Okay. Okay, sebelum kita pergi kepada applications Eurocode dalam kejuruteraan geoteknik, ada beberapa reasons why the Europe countries, for example German, kemudian Switzerland and any other developed country proposing their own Eurocode instead of using the national UK or using the what we call it British Standard Code. There's some considering factors such as sustainable development goal that they are aim to have carbon emissions, energy efficiency. So in terms of the material of the construction project, they try to minimize or optimum the cost project. So when you remember back, when you are designing using the British Standard Code, for example, or any codes in design, you may consider as a conservative concept or conservative design that may consume high cost of the materials constructions. In this time, when you are adopting Eurocode's standard in your design, is actually something you are minimizing in cost, meaning that all the factors will be minimized or will be modified by some factors. So faktor-faktor ni lah, faktor-faktor ni akan membantu kepada accuracy or design decisions that very optimum in terms of the material dan juga cost. So what we may expect from this course is that for this chapter, you are able to conceptualize the design for different geotechnical structures, able to design according to the specified code. Okay, dalam Eurocode, there are many what we call it as sections lah ataupun part. As you can see here, there are 10 Eurocodes beginning in the 1990. How it was started as a basis of structural design. So dalam section ni hanya introduce on the structural design. And then in the next following years, 1991 introduced Eurocode 1 on the actions on structure, following to this one until that in 1997, Eurocode 7 was introduced for geotechnical design. And in order to consider the effect of the seismic and earthquake, so there are another code ataupun section that introduced in the Eurocode 8 as a design of structure for earthquake resistance. So these are the things that Eurocode has, but in our course, in this chapter, we may only concern in the Eurocode 7 geotechnical design. Okay, there are two split part for Eurocode. First of all is the general rules, and then the second one is ground investigations and testing. So kalau tengok dalam British Standard pun dia menggunakan two split sections lah untuk introduce kepada general rules dan juga ground investigation and testing. And same thing to the Eurocode yang mana pada peringkat awal dia introduce about the structural basic concept. And this is how it shows the link between Eurocodes from the beginning as a basis of the structure that introduced to you as a structural safety, visibility, durability, and robustness. So all these things relates to the material strength and the durability of the material itself, how long the material can work or sustain to the load applied, and then the lifespan of the structure itself. So all these things you kena tahu lah. We're talking about the service limit, a design limit. Kemudian bila you dah faham all the concept, they bring to you to the next one. What are the factors, actions yang boleh berlaku ataupun boleh contribute to the structure stability or the structural failure? Within that one, after 1991, there were many Eurocode introduced, such as 1992 until 1999 yang melibat kandungan dalam design and detailing. And the next following years, 1997 and 1998, how it is work for geotechnical applications and how this is the flow ataupun the connections antara one Eurocode, walaupun Eurocode tu ada 10 dan dihasilkan pada tahun yang berbeza, how it is has connection from one to one until it final draft of final copy of the standard. Other than that, we also have Malaysian standard. Kalau tengok dekat UK pun diorang ada National Annex UK standard. So when you are doing anything lah, for example, if you practicing engineering in Malaysia, for example, you have to fulfill the National Malaysia standard. If you becoming a international practicing engineer outside Malaysia, for example in the UK, so you have to follow the UK standard. And then if you go to German or you work for a project in the German, so then you need to follow the Eurocode. So there's something that advantage and disadvantage using this certain or particular codes. So you have to find out ataupun the authority of this country restrict to have this kind of the of this code. So kena ikutlah kat mana you bekerja, kat mana you berada, di situlah you kena ikut dia punya standard ataupun peraturan. What the important things about the design when we bila kita design, of course kita nak design kita punya structure meet to the limit state. So dalam this kind of this Eurocode it shows to you if you have one structure here subjected to soil, we may have or we try to have a bell shape characteristic of the material behavior in terms of the probability and probability of occurrence. The limit state we try to meet at the mid of the bell curve. Same goes to the resistance. So dalam part ni kita ada action dan juga kita ada resistance. So parameter value coming from the material ke, coming from the action ke, coming from the resistance, we try to produce at the optimum one. Okay, the design limit state is involve the application of statistics to determine the level of safety required by or during the design process. So when we talk about limit state of the stability, which the retaining wall no longer satisfy the design performance requirement on the damage, economic loss ataupun unsafe. So the attention directed to unexpected, undesirable and unlikely states in which the construction is failing to perform satisfactorily. So this is our indicator lah bila kita design. If you remember you design concrete ke apa ke, you kena check dia punya shear checking, you kena check moment check, you kena tengok apa any forces that act to the structure safe. So dia ada tolerable value lah, tolerable limit value yang you kena reach. Kalau dia more than that, kita akan kata the structure fail. So you have to redesign, get the right dimensions of the structure. Okay, dalam this case, selalunya talking about the parameters in the design, we look at the strength, loads and geometric features. So have to check the structure will not fail under this specific value. So the degree of pessimism associated with the selected parameters depends upon the severity or consequences of the particular limit state. Okay, I think that this one is not so important. Okay. What are in the Eurocode 7? For the first part 1, it has general rules such as basics of geotechnical design, geotechnical data, supervisions of construction, pile foundations, effect of water, of embankment field, etc. So bila kita look at to this one, is a very common things lah. We talking about geotech, kita nak tengok dari segi construction, operation, procedure, and then kalau nak design untuk pile macam mana, nak design untuk retaining wall macam mana. So you can see from the part 1 Eurocode. Kalau you want to know the properties of the soil, the site investigation, soil testing, so yang tu you kena pergi kepada part number 2. Okay, this is actually we are trying to explain, I am trying to explain you on the introductions on the Eurocode sebelum kita pergi kepada design stage lah. Dalam European Geotechnical Codes, how it work. Contohnya kita bermula dengan identification and classifications of the standard that we use. Kemudian we identify test standard and technical spec for the ground properties. And then before we can have the geotechnical design, all those informations from the testing and from the structural design, or from the actions on structure kena ada dulu sebelum kita boleh pergi kepada state design dan juga analisis. Lepas tu lepas kita dah design, kita akan bawa kita punya design untuk real state lah. Real state yang mana construction stage. Construction stage ni we look at on the structural Eurocodes yang kita tak mention pada awal tadi lah, berkaitan dengan seismic impact ke, seismic effect ke. Kemudian ada tak yang melibatkan special geotechnical works yang perlu dilakukan di tapak. Sebab bila kita buat design in the early stage ataupun preliminary stage, we only got informations from the public authority and then from the standard from the other report project, and all those things pada peringkat their study is something that we may have at the beginning. Kemudian bila you want to construct the geotechnical project on the site, so maybe something that unexpected, unprecedented behavior ataupun unprecedented informations yang you perlu add on to your design. Yang tu yang kena buat balik lah, considerations and design back calculation or etc. Okay, the introduction about the basis of geotechnical design in Eurocode. It is introduced as a principle denoted as a P, and also another one as the application rules. The principles are unique statement or definition that must be adopted, while application rules offer examples of how to ensure that the principle adhere to and thus offer guidance to the designer in the following principle. So dalam permulaan awal untuk kita pakai Eurocode 7 ataupun geotechnical design, you have to differentiate lah apa dia principle, apa dia action rules, kemudian macam mana kita nak make sure that our design tu dia dah limit to limit state design. So ada beberapa cara yang mana kita kena verify limit state through calculation, prescriptive measures, experimental models and load tests, and lastly observational methods. Okay, untuk kategori risiko, geotechnical application can be categorized into 3. For the first category 1 yang mana kurang less risk impact. So projek-projek kecil lah kan yang kalau kita tengok it's a geotechnical work tapi dia tak deal with the structure sangat. So kita boleh categorizekan risiko kategori 1. Kalau dia melibatkan constructions of the geotechnical structure or applications in the retaining wall, foundations, it can be categorized as a risk 2. While structure yang tak termasuk dalam kategori 1 dan 2 is under risk 3. So mostly geotechnical structures ni kita categorize dia punya risiko dalam kategori 2. Okay, yang ni adalah step calculations untuk geotechnical design. So you have to differentiate lah. Sebenarnya kita nak, bila kita design, kita kena ada design value. Lastly, bila kita dah following to the step design value, kita dah tengok pada action factor, kita dah tengok pada material factor, kita dah tengok pada resistance factor. The last thing you need to check adalah limit state. Limit state ni can be checked from the moment ke, from the force subjected to the structure. Kalau destabilizing moment less than stabilizing moment, so the structure reach to the limit state or it is satisfied. Kalau kata destabilizing moment more than stabilizing moment destabilizing more than stabilizing moment, so it is not satisfied in terms of the limit state. So kena balik design semula, check the factor of safety, baru you boleh satisfied your design. Okay, for the first step, you have to establish the design value of actions and geometrical data, and then establish design values of ground properties and resistance. So nampaklah kan two things yang very important for the first one. Kita nak kena tahu apa actions coming from that load ke, live load ke, kemudian dia punya dimension. And the next one is the ground properties ataupun soil properties, and what is the resistance factors. And then you define the limit state must be not exceeded daripada yang ditetapkan. And then we have to perform relevant geotechnical analysis, show by calculation the limit will not be exceeded. This is what we call as a verifications. Okay, what is the design value? Just now it says that the design value ni coming from the action dan juga geometrical data. Design value of actions, for example, are derived by multiplying the representative value by the appreciated partial factor of safety. So maksudnya dalam Eurocode ni dia banyak introduce faktor-faktor untuk modify parameter yang terlibat dalam design value. So setiap single thing yang you consider as a factor in your design will be modified by this factor. Same goes to the geotechnical parameters ST. Dia punya design value geotechnical parameters are derived by dividing the characteristic value SK by the appreciated partial factor. So ada satu ni dia kena multiply, yang ni kena multiply. This one is multiply untuk actions. Tapi untuk geotechnical parameter dia kena divide. So dia berbeza lah. And then kalau untuk resistance pula, the design value of actions and parameter. Maknanya dia combinations daripada actions dan juga ground parameters. So either can be taken as equal R or equal to the reduced value of R. So that is divided by the action factor FOS. So the choice of which partial factor of safety to use is governed by the nature of the action and by the design approach being used. So for this action, the design value of the action, it can be counted from the permanent G, and permanent G ni dia can be classified for favorable ataupun unfavorable. Dalam soalan dia akan mentions lah. Kemudian variable Q, accidental A dan juga seismic. So design value by actions ni dia ada 1, 2, 3, 4 faktor lah. Faktor ataupun kesan yang memberi kepada reka bentuk anda lah. Okay, ini pun I think the same one. Okay, the characteristic value. Characteristic value must be based on the result from laboratory and field test, further addressing the fact that statistical procedure is not readily applicable to soil. So the code states that the characteristic value should be taken as a cautious estimate of the value affecting the occurrence limit state. Okay, next is the partial factor of safety. Partial factor of safety ni can come from the actions, material properties dan juga resistance. So this means that partial factor of safety are applied to all actions, material properties and resistance for each limit state being checked. So material properties ni is highlighted to the geotechnical data. Actions ni it can be under 4 macam saya sebut tadi lah. G tadi tu apa? G unfavorable, favorable, permanent. From the permanent ataupun from the variable ataupun from the actions. Material properties ni from the geotechnical data. Okay, partial factors on actions are denoted by the symbol gamma P. Untuk material pula partial factor dia gamma M, untuk resistance is gamma R. So partial factor ni juga dia boleh affected to the properties of the soil. Contohnya shear resistance dan juga cohesions. So kalau you nampak, that's why it says that as I explained in the early class, Eurocode very orang kata design yang menentukan optimum value of your cost dimension, because every single factors, every single effect, there will be some additional stage of the calculation yang mana you perlu divide dengan partial factor. Ada faktor-faktor yang you kena masukkan dalam reka bentuk anda dari segi nilai material, dari segi nilai shearing resistance ataupun parameters of geotechnics, kemudian dari segi actions dia, semua tu perlu difactorizekan dengan dia punya some value. So that's why when you get all this data untuk design tu, dia adalah design yang paling optimum sebab dia dah consider all those aspect dalam dia punya calculations. Dia divide dengan certain partial factors. Okay, this is a table that may guide you untuk determine the partial factor for EQ, GU and STR limit states. For example tadi kalau kata kita ada permanent actions G and then we have variable action. Action ni they can be classified into two lah. Satu permanent, satu lagi variable. Permanent ni something like loading yang you dah tahu berapa nilai beban dia. Itu pun dia boleh pecah pula dalam kategori unfavorable dan juga favorable. Accidental action dan juga kemudian materials such as tangent free, cohesion, undrained, unconfined. Semua ni dia ada nilai-nilai partial factor dia. Apa dia EQ? EQ is the static equilibrium limit state. Kemudian A1 is the partial actions approach 1, partial action approach 2, partial materials factor approach 1. Ini adalah design lah yang kita pakai dalam Eurocode. So I will explain later lah. Okay, partial factors and the design value. Tadi kita dah cerita pasal design value kan, macam mana kita nak dapat design value daripada nilai actions, sama ada permanent ataupun variable, kemudian daripada nilai materials ataupun daripada nilai resistance. So all this design value dia ada yang multiply, ada yang divided dengan partial factor. So the verifications of any limit state involve an assessment of the effect of the design action against the magnitude of the design resistance being offered by the structure. So in the analysis performed to check that the effect of the design action do not exceed the design resistance. So these are the keywords lah. Whatever you design pun dia mesti kurang daripada design resistance. Nanti kita akan tengoklah macam mana yang dikatakan nilai itu sepatutnya kecil daripada nilai design resistance. Okay, design value of the actions. So we want to calculate the design value of the actions. The design value of the actions involve multiplying characteristic by a correlation factor in the Eurocode, then multiplying the resulting representative value by a partial factor of safety. So dia punya step panjang lah. Memula calculate dengan correlation factor, kemudian dah dapat nilai tu FRP ni pula kita kena calculate dengan partial factor dia, baru you akan dapat untuk design. Okay, yang ni adalah table untuk nilai partial factors on action bergantung kepada jenis limit state awak. Kalau dikata equilibrium limit state, so table A1 lah kita kena refer. Kalau ada structure satisfy the geo limit state ataupun structure limit state, so we have to refer table A3. All that ones pun bergantung jugalah pada action tu permanent ataupun variable. Permanent, the symbol is the G, variable, the symbol is the A. So A1, A2 as I mentioned is approach 1, design combination 1, approach 1 dan ataupun approach 2. Okay, this is a step sebelum kita boleh dapat design action dan juga design effect of the actions. Kita nak tengok dia punya effect of the design to the structure stability or the failure. Sama ada our ED ni dia satisfy limit state ataupun not satisfy limit state, or it fulfill the resistance punya partial factor. Okay, it says that the design actions FD is equal to representative action FRP multiply dengan partial factor of safety. So sebelum boleh dapat representative action ni, characteristic action FK multiply dengan correlation factor gamma. Okay, dia punya step tu there are few things lah you have to understand before you can get the calculations answer. For example here, in order to calculate the design value of the action which having the magnitude 200 kilonewton with the partial factor of safety gamma F is a 1.35, determine the design value of the action. So the design value is equal to F representative darab dengan partial factor action 1.35. Partial factor of safety actions is a 1.35, so the answer is a 270. So yang ni nampak macam mudah kan, tapi sebenarnya bila dia applications untuk design tu is the complex lah, dia dah complex sikit. Tadi we talk about action, now we talk about material, the design value of the material ataupun geotechnical parameters. To reach the design value of the geotechnical parameter, the characteristic value is divided by the appropriate partial factor of safety. Just now I said kan, kalau untuk material ni kita akan divide dengan partial factor dia pula. So barulah kita dapat design parameter of the geotechnical properties. So again, this is also rely on the limit state apa yang you kena satisfy. are you satisfying for equivalent static limit state ataupun geo or structural limit state. For example here, kalau you nak tak tahu what is the partial factor of the angle of shearing resistance, satisfy AQU, so the value is 1.25. Different answer for Q ataupun structural limit state for different approach of design M1 ataupun M2. So the important parts about the design is in Eurocode is you need to understand what is the partial factor, what is the design value for action, for materials dan juga for resistance. So you will see that all three things that I mentioned just now will have different tables according to the limit state that you are trying to fulfill. Kemudian design approach apa yang you nak kena ikut. Okay, this is some examples. Another one, kalau you menggunakan National Annex MS ni in Malaysian, according to the AQU limit state for the design parameters ataupun design material parameters. So for angle of shearing resistance, so the answer partial factor dia adalah 1.1. Partial factor of safety lah sebenarnya. That's why I said, kalau dulu kan bila kita calculate kita nak dapatkan design load untuk foundation lah, strip footing for example, it's the simplest way. Kita calculate ultimate bearing capacity, kemudian kita bahagi dengan Q allowable, kita terus dapat factor of safety ataupun vice versa lah. If you want to know that your design load exceed ataupun less than working load, so the way is that kita Q allowable is equal to Q ultimate bahagi dengan factor of safety. Maknanya kita ambil yang total terus bahagi dengan factor of safety. Tapi bila you pakai Eurocode, setiap step your design calculations tu you kena bahagi dengan factor of safety. You kena ambil consideration effect factor of safety dia dalam action, dalam materials dan juga dalam resistance. Barulah you boleh calculate to the whole structure that you design. So nampaklah kat situ kan dia punya optimum design dan juga optimum cost. Maknanya mereka bentuk pada nilai yang optimum, bukan lagi pada nilai conservative value. Okay, if you want to know what is the design value of geotechnical parameters, this is example. So kita kena tahulah dia punya partial factor dia. For example here, the undrained cohesion is a 40 kPa, effective cohesion is a 5, effective internal friction angle is 27 degree. So gamma Cu, gamma C and other this thing ni, dia boleh dapat daripada this table, kalau you menggunakan Malaysian National Annex, ataupun daripada Eurocode table 1.5 I show just now. Dekat sini dia, sorry saya terpaksa patah. Kat sini dia ditunjukkan kalau untuk undrained shear strength, you nak you nak satisfy AQ limit, so kita kena ambil partial factor dia 1.4. Okay, sorry, kita kena ambil nilai dia 1.0 untuk M1 approach 1 dan juga M2 1.4 untuk approach 2 kalau you are fulfilling the geo ataupun structural limit state. Tapi kalau you hanya nak pakai EQ limit state, so kita just ambil value from here. So that's how they can get the value of the partial factors untuk geotechnical material properties. So I hope that this is not will be problem to you. Macam mana dia dapat 1.4, macam mana dia dapat 1.25. So what is the design value of the material? Cu, C effective D dan juga effective D. So dia just bahagikan nilai geotechnical parameter tu kepada partial factor. So the answer undrained cohesion is 28.5, effective cohesion is a 4 kPa and then effective internal friction angle is a 22.2 degree. So nampak setiap benda tu kita kena bahagi dengan faktor dia. Modify sikitlah nilai parameter daripada nilai asal. Okay, design effect of actions. So kalau you tengok dia punya stages of calculation step tu, kita determine design value, kemudian kita kena consider juga design effect and then kita kena check dia punya resistance. So when assessing the stability of the strength resistance of the structure, so it is the effect of actions that are considered These effects include the internal forces, moments, stresses and strain within the structure members, plus any deflection or rotation of the structure. So during the verifications of geotechnical strength, where the true limit state is used, some effect of the actions will depend on the strength of the ground, in addition to the magnitude of the applied actions and the dimensions of the structure. Thus, the effect of an action in the geolimit state is a function of the action, the material properties and the geometrical dimensions. So just now I showed to you table 1.5 kalau kita ada data-data partial factor untuk nilai limit state yang berbeza. For the first column contohnya EQ limit state. So you just take it the value from the EQ limit state. Kalau kata you want to fulfill the geotechnical limit states, so dia akan ada nilai A1, A2, M1, M2. Kemudian dia akan ada R1 dan juga R2. As I said just now, satu tu referring to the combinations, design approach 1, combination 1, design approach 2, combination 2. Nanti you akan nampak lah. Tapi untuk this part, in order to check the design effect of actions daripada permanent action ke ataupun variable actions tu, which may cause to the instability structure, for example bearing failure, sliding, rotation, semua ni kita akan look at the actions effect from the function of the action, material properties dan juga geometrical dimensions. So the ED, the effect of the actions, the design effect of the action is the function of the design action FD, design material property SD dan juga design dimensions. So kalau kata untuk you check stabilizing dengan destabilizing, it is the same. It's a function to the design value of the actions and material dan juga geometry. Okay, the design resistance. Design resistance is the last stage untuk design process dalam Eurocode 7. So it is same that function to the action, function to the material, function to the geometry, and you need to divide dengan partial resistance. Partial resistance dalam table 1.5 tadi tu yang dia indicate dengan simbol R. If you remember just now lah. Ataupun this table A6 showing to you the partial resistance factor for different piles. For example, driven pile dan juga pole pile. For design approach combination 1, for example, design approach combination 2, 3 and 4 for different structures of pile at the base or at the shaft or combine ataupun shaft in the tensions. So when you want to take the partial resistance value, you kena careful check design approach tu at which combination. Is it combination 1 ataupun combination 2? Kemudian you nak calculate pada base ataupun you nak calculate pada shaft. So you can see that for me lah Eurocode 7 ni dia agak macam very particular lah kan. Setiap design tu you kena bahagi dengan faktor-faktor dia kan. Kalau ikut cara kita dulu tu, faktor tu kita hanya buat sekali saja pada step yang terakhir kan. Kalau masa kita nak guna material untuk calculate ultimate bearing capacity ke apa ke, they just inserted the value dalam formula tu. Tak perlulah nak kena bahagi dulu dengan faktor dia baru kita boleh guna. Tapi inilah cara yang berbeza dengan Eurocode. Sebelum awak boleh guna nilai untuk reka bentuk tersebut, you kena faktorkan dia dulu, bahagikan dengan dia punya faktor ataupun design value tu boleh di multiply untuk dapatkan nilai tersebut. So I hope that you can see differences between conventional design code dengan Eurocode design. Okay, now as I mentioned, dalam table 1.5 tadi, you can have the EQ, SGR, Geo, UPL and hydrostatic ataupun hydraulic. EQ is the static equilibrium limit and STR is the structural limit. GEO is the geotechnical ultimate limit state and UPL more to the buoyancy or the water pressure and HYD is the hydraulic gradients. So what is the EQ? EQ is a loss of equilibrium of the structure or the ground considered as a rigid body in which the strength of the structural materials and the ground are insignificant in providing resistance. So dalam erti kata lain tu dia hanya kacau dari segi equilibrium dia saja. Dari segi dia punya strength dia ataupun other things, the service limit of the material tu less significant. Kita tak nampak sangat dia punya kesan ataupun pengaruh dia. Kalau kata structural limit state, you akan nampak the structure fail, ada breakage structure, bahagian-bahagian struktur yang rosak. Yang tu kita memang totally says that the structure has internal failure or excessive deformation of the structure or structural elements including floating spar or the basement walls in which the strength of the structural material is significant in providing the resistance. Geo-limit state is a failure or excessive deformations of the ground in which the strength of the soil or rock is significant in providing resistance. UPL is a loss of equilibrium of the structure or the ground due to uplift by water pressure or by other vertical actions. And HYD is a hydraulic heave, the internal erosion and piping in the ground caused by hydraulic gradients. So, kalau you tengok bila mana-mana subjek lah kan yang melibatkan design, selalunya jarang sangat tanya teori kan. Tapi untuk subjek ataupun khusus IC 612, it's a combined concept and also the calculations. So kalau you boleh agak lah, kalau nak tanya teori pun mana je lah, celah-celah mana dia nak tanya, so you dah boleh guess which section yang you kena hafal teori dia, which section yang you kena understand dia punya design proses dia. Okay, these are the examples for limit state failure for earth returning structure. Contohnya kalau kata figure A ni, you have a rigid foundations and then the footing may fail rotations ataupun overturning. So the category for failure adalah EQU limit state. Tapi kalau kata the foundation is founded on the soft soil and then overturning take place, you akan nampak kat sini dia dah tak fulfill the geotechnical consideration in terms of the stability. So that goes to the geolimit state. Same to the bearing failure, you akan nampak lah dia memang bukan EQ tapi dia adalah geolimit state. Same thing to figure D and also figure E. Figure F ni you memang totally nampak dah. Structure returning wall ni dia tak having the overturning, bearing failure pun tak, sliding pun tak. Tapi dia dah memang totally break into two sections. So yang ni adalah structural failure ataupun structural limit state. Okay, the next one, talking about the limit state, kita dah tengok effect of the design value, kemudian kita dah tengok dia punya resistance, effect. And then we want to check that sama ada dia satisfy or not satisfying. So one thing that you have to look at bila dia melibatkan EQ limit state, kita akan tengok destabilizing design limit is less or equal to the stabilizing design limit. Kalau dia melibatkan structural or geo limit state, effect design equal to less to the resistant design. Kalau dia melibatkan UPL limit state, so this is the formula lah untuk you check. Kalau hydraulic failure, this part. So saya just cover untuk the sections lah, ataupun sebab kita sekarang ni EC7 kan, EC7 tu lebih kepada Eurocode 7. So saya tak highlight sangat lah yang dua bawah ni. Okay, yang ni adalah proses macam mana you nak design dalam Eurocode 7 to fulfill the EQ limit state. Maknanya pada stage mana yang kita kata kita dah reach to the last step ataupun last stage, bila you dah check limit state dia satisfying or not satisfying. Kalau EQ limit state from the beginning of your design and analysis tu, you dah identify destabilizing moment ke, destabilizing forces from the actions and effect. Kemudian you dah buat some calculations, you dah masukkan partial factors and then you get the value and you calculate for the design effect or the destabilizing action. The other side pula you calculate for stabilizing action and effect and then you masukkan partial factor dia, you have the value for stabilizing action, you tengok nilai dia kecil ke besar. Kalau kata destabilizing design effect tu lebih kecil daripada stabilizing design effect on the right side, so kita dah boleh satisfy lah, tak perlu lagi nak buat design semula. Okay, ini adalah some example how we can check the effect of the limit state, sama ada EQ ataupun structural, but this example is focusing on the EQ limit state. If you are given a reinforced concrete gravity returning wall with the width 2 meter returning a homogeneous granular field as shown in this figure, so the resultant active thrust due to retained soil is equals to 66.5 kN and the lateral thrust from the surcharge is equal to 15.1 kN. Check the safety of the wall against the EQ limit state of Eurocode. Assume ranking condition prevail and that the wall rests on the steel layer. Gambar ni biasa dah kita tengok kan, kita ada destabilizing forces ataupun destabilizing moment from this active thrust PA dan juga PQ, which 15.1 kN and 6.5 kN. So what we need to calculate is the destabilizing actions dan juga stabilizing actions. So the stabilizing action from the both permanent and temporary, while stabilizing actions coming from the permanent actions gamma G, destabilizing dan juga variables action gamma Q. Okay, then you have to identify lah, kalau ikut stage A1 kita kena identify mana thrust ataupun moment yang give you destabilizing ataupun stabilizing actions. So PA dan PQ are destabilizing actions. Weak of wall is the stabilizing actions. So again, untuk this part, in order to get the design actions value, kita akan multiply dengan partial factor. So partial factor untuk permanent actions gamma G is 1.1, while variable action for PQ is 1.5, and then stabilizing permanent action untuk wall is 0.9. So these are the modified value after considered the partial factors in the calculations. So the stability is assessed by considering the moment equilibrium about point A. So kita ambil lagi moment pada titik A. So the same thing as you did in the conventional method. So apa kita dapat, the destabilizing moment daripada sini kan, first PA dan juga PQ. So you ambil moment pada A, you akan dapat dia punya nilai 73.2 darab dengan 4/3 plus dengan 22.7 times dengan 2. So taking moment at here kan, jumlahkan dia, so you akan dapat destabilizing moment is 143 kN meter and stabilizing moment is 100 kN meter. So what can you conclude is the stabilizing moment 143 kN meter is less or equal to the 180 kN meter from weight of the wall. So that EQ limit state is satisfied. Yang ni yang kita nak check the last stage our design. So now points, you calculate design value action, design value material, design value resistance, and then you tak buat pun dia punya limit state, you tak check pun, you tak verify limit state fulfill EQ ke fulfill the geo limit state. Just now dia melibatkan EQ limit state. Kalau kata EQ limit state ni lebih kepada structural limit state, kita nak check dia safe or not. And then untuk geo limit state, it's the same thing that we want to check, tapi we have to see the significance on the geotechnical aspect lah. For this part bila kita nak design dia, kita akan verify antara design effect dan juga the resistant design ataupun design resistant. Design effect is coming from the actions dan juga effect. So how do we get that ones? Remember, in order to get FD, design actions FD, kita akan multiply antara representative action F darab dengan, bukan darab, darab dengan partial factor. So you akan dapat FD. Kemudian design effect of action ED ni you akan bahagi dengan dia punya partial factor. So you akan dapat some value of the design effect. And then to get the resistance design RT, kita akan characterize from the material properties and the resistance. Okay. And then we divide with the partial factor for the design material properties ST, and from that kita bahagi dengan partial factor resistance. So lastly kita akan dapat RD. Last we have to check ED less or equal to the RD. Okay, this is one example for the geo limit state. Kalau you look at from here, the ED is less than or equal to the ground resistance RD. So kalau this kind of thing you have, so kita boleh kata it is satisfied lah. So boleh baca lah dekat atas ni. Okay, now we go to the design approach. As I mentioned earlier, in the stage of the slides, bila you look at to the table 1.5 for partial factors, sama ada effect and action, materials dan resistance, you may see that column for A1, A2, M1, M2, R1 and R2. That one is referring to the design approach 1, combination 1 ataupun combination 2. Selain daripada tu, kita ada design approach 2 and also design approach 3. In Malaysia, ataupun dekat Malaysia dan juga National UK Standard, we always use the design approach 1. So, kita menggunakan design approach 1, combination 1 dan juga combination 2. What is the combination 1? Combination 1 is where you have to take the design effect with the functions of the partial factor action, partial factor material and also partial factor resistance. Semua tu satu-satu sebab dia adalah combination 1. Tapi kalau you are asking to design approach 1, combination 2, you have to refer the design effect with the functions of action 2, material 2, but resistance remain 1. So you kena careful kat situ. Design approach 2, yang ni macam you boleh tengok lah. Tapi setakat ni kita hanya menggunakan yang ni saja untuk kita punya practice and calculations. So this is the same thing as earlier I show you. Table 5.1 Mungkin tadi saya ada salah sebut lah. The sets for action denoted by A. Actions ni dia boleh jadi permanent ataupun variable. Kemudian material properties denoted by M. Ground resistance denoted by R. So tadi kita nak check effect of the design must be equal ataupun less than design resistance. So benda tu kalau you fulfilling the geo limit state. Kalau EQ limit state, nilai dia dekat bahagian kolom yang ni. Okay, macam mana kita nak guna dia punya design approach satu ke apa benda ni lah kan. Okay, this is one example. DA11 is referring to the design approach 1, combination 1. Design approach 1, combination 2. You can see that for permanent actions, nilai dia 1.35. Variable action Q, nilai dia adalah 1.5. And then the partial factor action permanent, partial factor variable Q, and then this factor for G pun you can have from this table. Okay, for example, a concrete foundation is to be cast into a soil deposit as shown in the figure. So it gives to you the value for actions permanent and variable VG and VQ 600 kN and 150 kN. So during a check for bearing resistance, so RD lah ni kan, the vertical representative action VGK and VK are considered as unfavorable. Nampak tu dia dah bagi tahu lah. So maknanya nanti you kena tengok pada table 5.1 tu dekat bahagian unfavorable. So the ground beneath the foundation has the following characteristic value. So the material properties lah, 40 kPa, CK5 and VK25. Determine the values of each action for each design approach. Maknanya kat sini design approach 1, combination 1 and combination 2. Determine the design value of each property for each design approach. So the answer is that first kita keluarkan dulu dia punya partial factor for G design material for GD is equal to representative factor multiply dengan partial factor, unfavorable permanent G gamma G equal to 110 kilonewton from the action factors. And then for properties ataupun material, so these are the partial factor dia. By design action 1 combination 2 untuk unfavorable. So 1.25 for the fee. Ini nilai dia. Sebab dia nak design approach 1, 2. So kita dapat 1.25. So just get the last one lah, apa nilai nilai design dia lepas kita dah bahagi ataupun kita darab dengan dia punya partial factor. The last not least, when you check the design effect ataupun design resistance tu, kita akan ada lagi additional that we call as a over design factor, RD over dengan ED. We want to check sama ada design resistance to the design effect ni can give what's the value. Yang ni pun some additional checking lah other than daripada limit state. Okay, we take last serviceability. Okay, we take 5 sebelum kita sambung dengan geotechnical structure applications dalam 11-5 minit nanti. Okay. Saya nak panggil Atika. Apa awak faham? Boleh tak you summary-kan? Hello. Nur Atika, apa yang awak faham daripada Eurocode 7 ni? Pakat. Kelas, mana yang lain? Patrick ke, Afika ke, Sharizal ke, Elias ke, apa yang you want to say about this Eurocode? Eurocode 7 ni, dia panjang lah kalau ikut summary yang saya boleh katakan. Tapi saya nak you ada gambaran what are you going to do bila you are having this apa kata soalan lah. Kita punya online class masih lagi sama, yang mana attendance saya akan ambil daripada you future untuk 2 jam. So remaining 1 hour tu I leave it to you untuk buat activities dalam learning activity, soalan yang berkaitan dengan kita punya online topik online lecture lah. Okay, siapa yang boleh buat ringkasan ataupun apa yang you faham daripada bab 3 application pertama? Guys, where are you? Adrian, apa you faham?
Dia kira basic untuk design.
Okay. Banyak-banyak cerita tu apa yang tangkap kepala awak?
Macam partial factor.
Okay. Betul. Mostly apa yang daripada kita tentukan design value, kemudian kita nak tengok design effect, and then we want to check the resistance. Semua tu akan ada proses fasa yang melibatkan partial factor. Partial factor ni dia ada beberapa considerations ataupun input yang mempengaruhi kepada partial factor ataupun design value dan juga effect. Okay. Saya pun mana ada masa lah. Nanti you pun ada masa kan baca sendiri. Kita sambung yang seterusnya. Okay, apa yang saya try ringkaskan sebab yelah benda banyak kan, so kita tak nak mengelirukan. You can see or I try my best to make you understand by having these flowcharts. So what exactly is C7? Tak kisahlah foundations ke apa, tapi yang ni saya letak dekat topik foundation lah. It's actually bila kita nak design untuk geotechnical design, for sure kita akan mostly check on the geo limit state. Ataupun kita boleh tengok juga structure limit state. Kita nak tengoklah structure tu safe or not safe in terms of dia fail lebih pada geo limit state ataupun dia adalah structure limit state. What can be categorized for these sections design is that first you need to determine design value. Design value ni sebelum kita boleh dapat design value yang terakhir tu, kita kena dapatkan representative action dia, FREP. Kemudian you multiply dengan partial factor, baru you akan dapat design value. All that things relates from the basic principles ataupun applications rule. When we talk about the design value ni, kita melihat daripada design value from actions dan juga effect. Kemudian geotechnical parameters such as material. Materials ni it can be cohesion, undrained ataupun drain, effective or total. Kemudian internal frictions angle, and the next one is a resistance. Ini baru dia punya value saja, kita tak tengok kepada design approach. Dalam design approach ni saya boleh keluarkan satu lagi lah, sebab kita dah tahu design value, kita nak tahu dia punya design approach. Kalau kita bawa to that one here, design approach ni kita ada combinations design approach 1, combination 1 dan juga design approach 1 combination 2. Yang tu kita lebih fokus. Bila you dah settle part on the design value ni, we go to the next one, checking the factor of safety, yang mana partial factor yang kita introduce kat sini datang daripada ataupun based on the actions dan juga effect. Effect apa? Kita nak tengok pada effect permanent G ataupun variable actions Q ataupun accidental A dan juga seismic AE. After that, we need to check our design satisfy limit state EQ ataupun geo limit state. And the next one, we go to the limit state verification. You can do by calculations ataupun prescriptive, experimental model and load test, and lastly by observational methods. Dekat limit state verifications ni, kita akan ada over design factor yang mana RT bahagi dengan design effect. At this particular sections pun dalam geo limit state kita akan tengok design effect which supposedly lesser or equal to the design resistance. So these are the things yang bila you relates ataupun you get involved dengan geotechnical EC7 design, these are the things yang you kena tengok. So yang ni pun dah explain. Okay, applications to the shallow foundations. Shallow foundations ni dalam Eurocode 7 Annex T, depth factors are excluded. Mana datang depth factor ni? If you remember, kalau kita design ultimate bearing capacity for shallow foundations, selalunya kita pakai terzagi lah kan. Terzagi ni pula formula dia varies according to the shape footing. Sama ada strip, rectangular, strip footing, rectangular, circular. So tiga bentuk footing ni ada different factor untuk ultimate bearing capacity tersegi formula. That's okay sebab dia hanya melibatkan term untuk soil parameter cohesion for example, and then term number 2 overburden stress, and then term number 3 adalah unit weight. Dia tak ada faktor tambahan. Tapi bila you apply Meyerhof ultimate bearing capacity to determine the QU, these are the factors yang mana you akan nampak ada faktor S, ada faktor I, ada faktor D. Kemudian term nombor 2 pun ada faktor SID lagi. Term nombor 3 pun again you may see or find faktor SID. So SC, SQ and S are shape factors. IC, Q, gamma are inclination factors. DC, DQ and D gamma are depth factors. So the good things about E7 untuk shallow foundations, the last factors, depth factors ni dia tak masuk dalam awak punya design lah. So kita tak perlu consider dia punya effect. Okay, SC ni represent term number 1 lah, SQ represent term number 2, S gamma represent term number 3. Okay, what is the NC, NQ and gamma? Yang ni saya just refresh balik lah ya. Kalau ikutkan kita boleh ambil daripada tersegi bearing capacity factor ataupun modified bearing capacity factor by using this formula, and then the shape factors as you can get from here ataupun the depth factor can be found from this table. So ini adalah some indicator or typical value how you can get the factors for shape and factors for D. Okay, yang ni I explain just now dah tadi kalau kita menggunakan formula. Okay, another one, bila kita design untuk foundations dia akan ada something additional that you may look at effective length dan juga effective width B and the eccentricity of the bearing pressure. So the overall eccentricity of the bearing pressure E must be considered the self weight of the foundation and is equal to as this formula lah. P is referring to load, EP is the eccentricity of the loading, P is the loading value, W is the self weight of the footing. Look at to the one example here. So they check safe bearing capacity from two different approaches. Satu kaedah tradisional, satu lagi menggunakan EC7. So apa yang they try to show that you may have the same answer lah, same value. Kalau you check limit state pun, kalau you check dia punya design requirement pun, they are satisfied from different approach. traditional ataupun Eurocode. But here is a process lah, macam mana you nak calculate until to the last step untuk confirm that the footing is safe from the bearing failure. Okay, yang ni dia punya step macam biasalah. Okay, first of all, you kena calculate self-weight footing, berapa nilai dia. Yang ni dia start dengan conventional lah. Conventional ni saya just refresh balik lah. Weight of soil, how does it calculates to this problem. And then the total weight of foundation plus dengan soil, so we have that one. Eccentricity of bearing pressure. Eccentricity bearing pressure ni dia cover dalam kat mana? Selalunya kita nak, dia adalah last stage untuk check design foundation awak tu selamat tak selamat. Selalu kita buat overturning, sliding. Yang ni adalah bearing pressure. So this is the calculations involved untuk bearing pressure. After you calculated the eccentricity bearing pressure, you kena check pula lah dia punya eccentricity loading tu. So E, dia punya conditions, E less or equal to the B over 6. So the effective width of footing is 1.3, effective length kat sini sebabkan dia ada continuous footing. So the shape factor is 1.0, the depth factor is 1.23, and the safe bearing capacity, yang ni dia, this is the exact formula lah. Lastly, they calculate as a 73.2 kPa, and thus safe bearing load is a 95.2 kN per meter run. So I don't want to focus on this traditional method approach. I like to look at the Eurocode 7 geo-limit state. So yang ni dia dah highlight geo-limit state. Maknanya dalam geo-limit state ni kita kena consider the actions and effect of the design in the design. For example here, untuk EC7 geo-limit state, design approach 1, combination 1, you kena dapatkan dia punya partial factor sets lah. A1 apa, M1, R1 dia apa. A is the action, M is the material, R is the resistance. So look at from the table. For permanent unfavorable actions, the value is 1.35, and then variable action gamma Q is a 1.5. Material partial factor untuk approach 1, combination 1, the gamma Cu is 1.0, dan juga resistance is 1.0. So the design value material property is a 30 kPa. So dia bahagi dah dengan partial factor dia. And the design action from the foundations and also from the line load, this is what they can have from here is you multiply dengan partial factor unfavorable permanent action. And for the load also similar because this is actions value tau, kita nak tengok design actions, so kita multiply dengan dia punya partial factor. So the effect of the design actions, so the vertical force is 108 kN per meter run. The eccentricity of the bearing is 0.248. And then the condition is that since eccentricity is less or equal to B over 6, so the effective width of the footing is 1.3 meter. So the design resistance, so now kita nak calculate lah design resistance dia. First you kena dapatkan the ultimate bearing capacity from the Meyerhoff punya formula having the shape function. And then you check the over design factor dan juga bearing resistance. So in the bearing resistance, we calculate the ultimate bearing pressure to the partial factor resistance as a 1. So the bearing resistance is equal to 220 kN per meter run, and we want to check the over design factor. Over design factor is a design resistance bahagi dengan design factor actions. So 108 ni datang daripada mana? 108 is coming from here. Design action, effect of the design actions. So what we can have is that since the design factor more than 1, so the geo-limit state requirement is satisfied. Maknanya nilai dia besar daripada yang ditetapkan minimum standard. So the design is acceptable lah for this kind of bearing pressure. Kalau menggunakan combination tu, the same step, the same process, the only difference are partial factor values. So partial factor values ni you kena cari yang barulah semua untuk unfavorable permanent action, kemudian and the resistant partial factor ni selalunya sama. Kita pakai approach 1, so dia tak ada masalah. Okay, for this example, I will not cover because we have another last part untuk foundations, iaitu piling ataupun pile foundations. So this part I leave it to you untuk go through. Dia punya step untuk design dalam Eurocode benda yang sama. Dia the only thing is that partial values. Yang penting kat situ partial values. You nak ambil table mana, nilai dia berapa, combination 1 ke combination 2. Kalau design action nak perlu bahagi ke nak perlu darab dengan partial factor. Itu yang you kena differentiate. Okay, this is most important part. I think that for the EC7 because it's quite kalau you look at the applications pile is most in all infrastructures project. Dalam infrastructure projects ni, piling is the important structure. It's a long slender member yang carry loading maximum, for example, yang mana they can go more deeper than 3 meter. So bila kata you design in proper way, you have a wrong design in upper shape, so you may bear the consequences. But since that we are very early in this Eurocode 7, so the piling in the Eurocode 7 approach is something that you have to look at closely lah. I think that what I want to highlight for the pile foundations application by EC7, something that you have to look at very closely on the part of ground resistance dan juga compressive loading. So dalam this part they are very easy because the applications for the first calculation on the first single pile design. Maknanya dalam topik ni dia hanya cover macam mana nak design untuk single pile. Kalau you dah tahu design single pile, dah tak ada masalah. Nak design pile group pun senang. Sebab pile group tu nanti kita hanya nak dapatkan total pile group capacity tu kita kena multiply dengan dia punya efficiency lah. Kalau satu pile boleh carry 500 kN load, kalau you ada 4 piles, so 2000 lah. That's how easier way kan dengan efficiency factor yang kita pertimbangkan. So that's why dalam ni you akan nampak I hanya cover design single pile sahajalah by using the Eurocode. But the thing is that we need to check on the ground resistance LCD failure through the compressive loading of the pile. Okay. So yang ni dia punya limit state lah, condition. Masih lagi sama, kita menggunakan design approach 1, combination 1 and combination 2. So M1 is used for calculating pile resistance. And then M2 is used for calculating unfavorable actions on piles. So the characteristic value is obtained by one of the 3 approaches from static load test, ground test ataupun dynamic test result. What is the characteristic value? Characteristic value ni it tells you that the partial factors that affect to the pile structures at the base ataupun at the shaft ataupun combined structures base dan juga shaft. Dalam this part, it says that the design resistance is a function to the action FD, SD is the material and AD is the geometric of the pile itself. So dia punya formula, you akan nampak lah how it is calculated dengan consider the partial factor resistance. And these are the tables showing to you the partial resistance factors for different pile, for example, for different structures at the base, shaft, combined ataupun shaft intention, ataupun the static load test too for characteristic values from the board pile punya result. Okay, this is the summary how you can get the resistant design due to the compressive loading. Okay, for example, if you have a different pile types according to the soil effect for pile ataupun driven piles ataupun combination ataupun combined pile. So kalau kita nak analyze in order to get the correlation factors, kita kena tengok kita punya karakteristik value loading tu is on base what? Testing on bore par ke, testing on driven par ke, ataupun dia testing on the combined par. Lepas you dah determine the par type, is not to determine characteristic value. Characteristic value ni lah yang I say that it can have from the static load test, from the ground test ataupun from the dynamic test. Dalam static load test ataupun ground test or the dynamic test ni, dia akan test pada many number of pars. They can test on the 5 pars, they can test on the 4 pars. So you kena tengok dia punya resistance of the pars tersebut. So berapa nilai dia. But then when we calculate for the resistance factor tu, kita akan tengok secara keseluruhan lah. Tapi untuk recording dia punya loading tu, dia akan record par 1 berapa nilai loading dia, par 2 berapa nilai loading. Nanti I akan show you later. Lepas you dah determine characteristic value from the static load test, ground test, dynamic test ni loading dia berapa. The next one is we want to design standard for compressive resistance by knowing the correlation factor. Correlation factor 1, correlation factor 2. Kalau you ambil correlation 1 is used to calculate RC mean purata. Kalau you guna correlation factor 2 is used to calculate RC minimum. While if you are using correlation factor 3, this is to calculate the design of the resistance from the, what we call it here, hari tu, it can be from the other design approach lah. They can be combinations 3 dan juga combinations 4. The same thing here, that 3 untuk calculate yang purata RC, 4 to calculate minimum RC. Lepas tu you kena check design factor ni, design standard code mana kita nak pakai, National NS ke, EC7 ke, ataupun selain daripada tu. Samalah daripada static load test ke, ground test ke, dynamic test. Kita nak design file ni, so kita nak kena tahu dia punya characteristic value datang daripada data, field data mana. Kemudian correlation factor untuk design approach combination mana yang kita kena tengok, fulfilling to which standard code. Okay, bila you dah dapat all those things, what we want to determine is the partial factor resistance at the base, partial resistance at the shaft, and ataupun combined ataupun shaft intentions. What is actually trying to say that daripada karakteristik design resistance from base ataupun from the shaft tu, kita kena dapatkan nilai yang paling rendah antara RC min ataupun RC minimum. Yang rendah tu lah yang kita akan guna dalam kita punya design as a design approach. So yang ni benda yang samalah, kita akan check the design resistance, satisfy which limit dan juga over design factor. Okay, combination 2 R4. So ini lebih kepada correlation 3 dan juga correlation factor 4. So this is what exactly showing to you is that as I said again, kita nak dapatkan resistance design resistance. The RC minimum is the mean measured resistance, RC minimum is the minimum measured resistance. So we have to calculate the compressive characteristic resistance value from combination between base and the shaft. And this is one of the these are tables showing to you correlation factors for different load testing. For example, here is static pilot test. Sama juga untuk table dekat bahagian sini pun is from the static pilot test. The only difference satu adalah daripada National NX Malaysia, satu lagi National NX from UK. So dia bagi pada awak nilai correlation factor from static pilot test for different pile numbers. Contohnya kalau kita ada static pilot test is a single pile. So correlation factor 1 is 1.4 and correlation factor 2 is 1.4 from UK standard. Kalau Malaysia standard pun nampak kebetulan samalah nilai dia kan. Tapi yang ni saya hanya nak tunjuk macam mana you nak dapat nilai tersebut. Kalau kata you got the questions and then you have to design according to the National Annex UK standard. This is the things that you may need to get the correlation factor 1 dan juga correlation factor 2. Okay, this is for driven pulse dan juga for pulse according to this standard. And then the partial resistance at base for combination 1, combination 2 dan juga combination 3 and 4 are show in this table for driven dan juga pulse. Kalau kata you having a CFA pulse, so nilai dia kena ambil daripada table CFA pulse lah. Jangan salah tengok table. Tengok betul-betul table daripada soalan dibagi apa lah. Selalunya dia bagilah. Kalau tak ada pun you kena cari partial question kan. Try practice buatlah soalan daripada partial questions. Okay, yang ni pun benda yang sama juga. Okay. Look at one example from here. Kita nak design static load. Kita nak design file from the static load test using to the UK National Annex. As I mentioned, there are few important information that you have to look on, such as the type of load test, kemudian the number of pulse, and then the type of pulse, sama ada board driven ataupun CFA pulse. These are the things that you have to focus on lah. Kemudian you kena tengok dia nak design dalam approach apa. Selalunya kita akan ambil design approach 1. Automatically you kena calculate for combine 1 dan juga combine 2. And then the next one is a standard code yang kita nak pakai. For example here for the particular question just now, first of all you kena calculate dia punya resistance design RC, mean purata 382, 425, 365, 412. Mana datang nilai ni? Nilai ni adalah nilai pi daripada measured load yang kita dapat tadi. Pi 1 dia punya measured load is 382. Pi nombor 2 measured load dia adalah 425. 3, 365, kemudian 4, 412. So kita jumlahkan, kita puratakan. Kalau kata ada pi nombor 5 pula kat sini dengan nilai dia 100 kN. So you kena bahagi 5 lah. So you akan dapat, contohnya kat sini dia bagi 4, dapat jawapan 396 kN. Minimum daripada 4 nilai loading tadi tu, measured load tu, antara yang paling rendah adalah 365 dari pi nombor 3. Betul tak Adrian?
Betul.
Betul kan? Okey. Seterusnya, bila kita dah dapat RC minimum, RC mean purata, kita kena dapatkan correlation factor. Okay, correlation factor ni ini kena reverse sikit lah ke atas nak tunjuk macam mana nak dapatkan nilai dia. Okay, correlation factor. Okay, this is the correlation factor. Sebab tadi soalan tu dia dah mention dia menggunakan National Annex UK. Kemudian dia adalah static load test. And then kita ada 4 pulse. So correlation factor 1 is a 1.34. Correlation factor 2 is a 1.15. Okay. Okay, I think that I was wrong referred to the table lah. Sepatutnya sorry, betul lah. Betul. 1.38 dan juga 1.15 daripada table yang saya tunjuk tadi. So apa gunanya nilai correlation factor ni? Nilai correlation factor ni untuk kita dapatkan resistance design yang telah difactorizekan dengan 1.38 dan juga 1.15. So bila dalam design kita takkan ambil the true the measured value ni, kita kena ambil the true value dia yang telah dibahagikan dengan faktor. So contoh tadi kita dah ada 287, kita ada 396 kan. 396 dia akan bahagi dengan correlation factor 1. Mana saya tahu ni daripada soalan. Soalan tu bukan soalan, daripada teori lah. Teori memang dah stated that kalau mana tadi? Ni. Ini dia punya teori. Kalau minimum tu, kalau purata kita kena bahagi dengan correlation 1. Kalau minimum kita kena bahagi dengan correlation factor. So you jangan terbalik pula. Bila you terbalik dia akan bagi jawapan yang salah lah. So that's why kat sini I highlighted that sebabkan kita calculate, kita nak dapat the true design value from average RC. So kita kena bahagi dengan correlation 1. Untuk value yang seterusnya daripada minimum value kita kena bahagi dengan correlation 2. So then you kena compare pula antara true value daripada purata dengan minimum, mana lagi rendah. Yang rendah itulah is our final design resistance. Lepas tu kita nak kena design according to the approach 1 dan juga combination 1 dan juga combination 2. Before that, you have to calculate ataupun determine the characteristic base resistance. Base resistance yang tadi kita dapat 287 ni is mewakili keseluruhan. So kita nak tahu shaft bawa berapa, base bawa berapa, resistance pada shaft berapa, resistance pada base berapa. How do we know that once the characteristic value tu? Okay, for example here, it says that the ratio of the base resistance to the shaft resistance is 3:1. 3:1 is a ratio. So bila kita jumlahkan 3:1 is the 4 kan. So dia bagi tahu juga 3:1 ataupun daripada information sini base resistance to shaft resistance. Makna kata 3 is referring to base, 1 is referring to shaft. Thus the base resistance of the shaft, base resistance of the pile design is 287 darab dengan 0.75. Mana datang 0.75? 3 bahagi dengan 4. 4 ni datang daripada mana? Tadi saya katakan 3 campur dengan 1. Kenapa kita ambil 3? Sebab first kita nak calculate untuk base resistance kan. So 3 bagi 4 dapat 0.75 darab dengan 287. Makna kata keseluruhan 287 base hanya bawa 21, bukanlah hanya bawa lah, base bawa yang paling banyak iaitu 215 kN. While shaft, perimeter pile tu hanya bawa 0.25. Mana datang 0.25? Can be calculated 1/4. Sebab kat sini saya dah beritahu kan, 3 rujuk kepada base, 1 rujuk kepada shaft resistance. So what the next step yang kita perlu kira adalah kita kena dapatkan the true characteristic lah ataupun the design resistance for this particular pile. And the next one is 287 bahagi dengan 1.0. 1.0 ni the thing that we can get from, ialah kita nak atas balik. Okay, kita pakai file apa? Soalan tu tadi bawa file Okay, soalan tadi bawa file. Okay, soalan bawa file. Approach 1, combination 1. So design resistance, partial factor for base is 1 sebab sekarang bore. And then shaft is a 1. Total is a 1. So bila you nak calculate untuk characteristic value according to the design approach, so first kita akan ambil total partial factor dulu. Tadi table ni saya dah rujuk, total is 1.0. Kemudian base pun 1.0 and shaft pun 1.0. So then you kena compare lah antara resistance asal tadi yang kita kira 287 tu. 287 datang dari mana-mana? Daripada sini yang minimum value yang kita dah compare antara mean correlation 1 dengan minimum correlation 2. The lesser is will be our value for these sections. And then bila kita calculate as a total, atas ni pun kita kena ambil total yang dibawa oleh pi lah. That's why kat sini pun kita hanya ambil partial factor resistance as a 1. Ataupun you boleh calculate split dalam kaedah berbeza. Contohnya 287 ni mewakili keseluruhan pi. Kalau you nak tengok base berapa, shaft berapa, so kita ambil karakteristik value tadi, 215 bahagi dengan partial factor untuk base 1.0, 72 bahagi dengan partial factor untuk shaft, coincident ni you dapat 287. Yang ni pun samalah, you kena buat, dia bukan, yang ni tak perlu buat perbandingan kecil besar, cuma you kena listkan dekat sini. Okay, you dapat 287 from total, you dapat 287 from the split calculation partial factor, and then recalculate untuk combination tu menggunakan partial set R4. So the total is 169. Kemudian untuk base dengan shaft, the partial factor is 1.7 and 1.4. So the answer is 178. And the next one, you kena list out semua nilai compressive resistance sebelum kita boleh decide which will be the best answer. So 287 is coming from here. 1, 2, kemudian 196 daripada yang tadi ni. And the last one is 178 is from here. So once you get all these things, you kena tengok yang paling minimum, sebab kat sini dia dah kata minimum. Of course kita kena design yang dalam this part dia consider the minimum lah. So the answer is 169 kilonewton. Okay, saya rasa saya habis kat sini dululah. So yang lain ni ambillah masa awak untuk fahamkan sendiri. So design by calculation ni pun sama je. Maksudnya apa yang dia nak tekankan adalah you boleh design resistance as a total dan juga design resistance as a base dan juga shaft. Okay, do you have any question?
No.
Okay, saya akhiri kelas saya dengan Assalamualaikum and bye. Boleh tak? Jangan lupa tahu buat projek awak. So kalau tak ada masa, bukan tak ada masa, kalau ada masa banyak ni, lepas dah buat learning activity tu kan, pergilah makmal komputer, siapkan awak punya Plexis tu. Plexis tu sebabkan kita dah guna Plexis baru dekat laptop, desktop di makmal ICT 1.5 tu. So in order to log in to the software, you kena follow instructions that I give you hari tu. You kena register pakai your username yang dah disetkan kat situ. Kemudian you klik forgot password, nanti dia akan link you kepada username ataupun email yang you dah set dalam tu. You klik login software tu dengan password yang diberikan dalam email awak. Lepas tu you boleh mula proses untuk buat modeling and simulation. Once you finish, you need to log out. And one thing is that saya nak maklumkan awak punya test 1 tu saya dah upload dekat OneNote Microsoft Team. So saya rasa dan saya harap awak tahu cara macam mana nak view awak punya result lah. The only difference that setiap anda ada 4 folder. Maknanya kata kalau you pergi OneNote tu, contohnya Muhammad ataupun Syarizal, dia akan ada 4 folder kat situ. Quizzes, ada folder quiz, ada folder homework, ada folder hands up, ada satu lagi apa nama folder tu. So you pergi ke folder quizzes, kat situ saya dah upload awak punya test 1 yang dah ditanda dan ada markah. Daripada situ you dah boleh plan untuk you punya future assessment marks lah. Sebab daripada test dengan quiz you dah tahu, you dah boleh agak lah you punya carry mark berapa. And I think that is actually every one of you has potential untuk pass. So now you hanya pulun betul-betul untuk quiz. Apa dia? You kena pulun betul-betul awak punya project dengan final assessment lah. Kalau tak ada awak punya test dekat dalam folder quiz tu, cuba cari dekat folder homework ataupun yang lain lah. Sebab ada time saya upload tu dia ada masalah internet connections. So I hope that you can find your check answer script. Tapi kebanyakan memang saya upload dekat quizzes folder. So that's end my lecture today. Assalamualaikum and bye-bye.
Thank you, madam.
Waalaikumsalam. Thank you, madam.
Okay, bye.
Thank you, madam.